Okay, the last thing I'd like to look at here is using linear combinations to solve a system of three equations. Now the process here is long, but as we go through it, make sure you get everything down and just kind of try and follow the process that I'm using. Okay, first of all, I'm going to just describe in general what I'm going to try and do. I'm going to first, since I'm starting with three equations with three unknowns, I'm going to try and eliminate a variable from two equations twice so that I end up with two equations with two unknowns. And then I can solve that system by eliminating a second variable from those two equations so that I have one equation with one unknown. And once I've done that, I can keep back substituting to find the other two variables. Now that sounds very confusing, I understand, but let's just see if we can walk through it. Up here, okay? You'll notice that these first two equations, one has a positive y and one has a negative y. Well, if I add those two equations together, I'll immediately get rid of the y and end up with an equation with just an x and a z in it. So that's the first thing I'm going to do here, is I'm going to use those two equations. I'm going to eliminate the y, so I have an equation with just an x and a z in it. Okay. Now I'm going to try and do the exact same thing again with two other equations. So as long as it's not the two same equations, this time I'm going to pick the second and third equation. Once again, I have a negative y here and a positive y here. They can be eliminated just by adding the two equations together. So that's what I'm going to do next. And once again, and I want to eliminate the same variable. Once again, I have an equation in terms of x and z. Okay? So now I have two equations in terms of x and z. So what I want to do is I want to solve that system. So the next step that I'm doing is I'm going to solve the system involving x and z. So if I do that, okay, well, one was a positive 6x here, and so was this one. So if I just take it, I multiply the bottom one through by negative 1, I get negative 6x minus 8z equals 0. And then I can add these two equations together. The 6x's cancel out, and I have a 16z and a negative 8z, which gives me 8z. And a 12 plus 0 is 12. So now I have one equation in terms of z, which we can easily solve. And now we know what z is. Okay? So we've found one of the variables. And that's the hardest part, is getting from 3 to 2 and then from 2 to 1. Once I have that, now we're going to do the back substituting. So I'm going to take z equals 1.5 and put it into either one of these equations, it doesn't matter which one, and solve for one of those variables. Okay? So what I'm going to do is I'm going to plug it in to this one right here. If I do that, I can solve for x. Okay? Because and it has to be into one of the ones with two variables before we can, go back to the three variable one. But if I do that, okay, plug in 1.5 for z, I can find the value of x. Therefore now x is negative 2. So now I know what two of the variables are. Z is 1.5 and x is negative 2. So now I'm going to take those two values and I'm going to plug them into any one of the three variable equations to solve for y. So that's what I'm doing, kind of my last step here. So I chose to go with this middle equation. Now it really doesn't matter which one you work with, I just chose to go with that one. I plug in negative 2 for x, I plug in 1.5 for y, or for z, excuse me, and now I'm going to solve that for y. Well, that's negative 2. 10 times 1.5 is 15. So if I take a positive 15 and a negative 2, I get a positive 13. So that gives me negative y equals 13, or negative y plus 13 equals 9, excuse me. Now if I subtract 13 from both sides, that means negative y is equal to negative 4, Therefore, y is equal to 4. So my final solution then would be that ordered triple, or those three together, which is -2, 4, 1.5. -2 being the x, 4 being the y, and 1.5 being the z. So that's how we solve an ordered triple.